The world is filled with a wide variety of ecosystems. One such of these ecosystems is the Arctic sea ice. I spent a lot of time out skidooing on the Arctic sea ice growing up, and when I heard the audio you hear in the background of this video, it immediately brought me back to the sounds of sea ice cracking around me and rivers flowing on the nearby tundra, while out on the ice and land with my family and friends in the early spring. This ecosystem, like most others around the world, exhibits many important ecological processes and concepts that help it thrive and flourish. Some of these processes and concepts include competition, predation, and nutrient and energy cycling. Our story begins with a polar bear traversing the sea ice in search of food. The majority of this animal's diet is made up of ring seals. This is an example of a predator-prey interaction between the polar bear and the seal. In its search for food, we can see examples of both intraspecific and interspecific competition. Intraspecific competition is competition among members of the same species for the same resources. This can be seen in polar bears as they compete with one another for the same food source, ring seals. Interspecific competition is competition between members of different species for the same resources. This type of competition can be seen between polar bears and walruses, as they are both animals that eat ring seals. Another group of mammals that are in interspecific competition with polar bears for ring seals are the Inuit. The Inuit are the indigenous people of Nunavut, where I'm from, along with the rest of northern Canada, as well as parts of Alaska and Greenland. The ring seal is a main food source for the Inuit people. When harvesting food, whether it be ring seals or other animals or plants, the Inuit always make sure to take only what they need and not be wasteful of what they do take. For example, when a seal is harvested, every part that can be used is. The edible parts are eaten either by the Inuit or fed to their dog teams, and what isn't eaten is turned into clothes, tools, lamp oil, games, etc. These Inuit practices of preventing waste and only taking what you need are ones I believe could significantly benefit current conservation efforts. While many important aspects of Arctic sea ice ecosystems can be seen with the naked eye, some aspects, which hold just as much importance, are less visible. A major example of this is nutrient cycling, particularly of carbon. Perennial or year-round ice cover limits air-sea exchange of carbon dioxide. Because of this, the majority of carbon cycling happens between the organisms of the ecosystem and the water. To look at this, we can look back to our polar bear eating the ringed seal. Some of the carbon and other nutrients in the ringed seal are passed to the polar bear upon ingestion to continue their journey through the food web. The rest of the seal's carbon and nutrients will be left in the carcass the polar bear leaves behind. This carcass will first be scavenged by animals like foxes, ravens, and other polar bears. As the ice melts when the summer comes, whatever remains of the seal will likely end up falling into the ocean. Here the remains will sink to the bottom of the ocean, where decomposers will break down the remainder of the carcass, returning its carbon and other nutrients to the food web. These decomposers will also respirate, releasing carbon dioxide into the water, where it will further continue its cycling. However, as perennial sea ice begins to melt, with increasing climate warming, another step in this cycling of carbon is amplified, the ocean uptake of atmospheric carbon. This process would have already occurred to a small degree when non-perennial parts of the sea ice melted or cracked, exposing the Arctic Ocean to the atmosphere. However, with the increased melting of perennial sea ice, more of the ocean becomes exposed to the atmosphere, allowing it to take up more carbon from the atmosphere. This may sound good in theory, as we know the more carbon we have in the atmosphere, the more we amplify the greenhouse effect, causing global temperatures to rise detrimentally. However, this increased uptake of carbon into the ocean causes ocean acidification, which could potentially be harmful to many members of the current ecosystem, including algae, zooplankton, and fish. Because of this, we must work to decrease our carbon emissions if we have any hope of protecting this beautiful ecosystem and all the others around the world from the negative effects of global warming. That concludes my video presentation. I hope you've learned something from this and that you take what you've learned with you moving forward and put it to use to protect the amazing ecosystems throughout this big, beautiful planet we call home. Thank you for watching.